All right, the second method we're going to use to solve systems of equations is solving by elimination, which is either addition or subtraction. We're going to do it with addition. You can do it with subtraction too, but addition typically works better because people tend to make fewer mistakes when they're adding than when they're subtracting. So this technique works really well when it's kind of awkward to isolate one of the variables. So your whole purpose is to get rid of one of the variables entirely. And again, we're going to get one equation and one unknown. And we're going to be doing this by adding or subtracting multiples of each equation to each other. So like I said, we're going to look for pairs of opposites so that we can add them rather than subtract them. So again, I like to label these 1 and 2 so I can see what I'm doing. So here, if we wanted to do this by substitution, to solve for x, we'd have to divide by 4. To solve for 3, we'd have to, or y, we'd have to divide by 3. Here, we'd have to divide by 2 or 5, and it's just not pretty because we end up getting fractions that aren't fun to work with. So we're going to do this by multiplying one of these equations by something and then adding them together. So I can see here 4 is a multiple of 2. So if I multiplied 2 by 2, I would get 4, but I want them to be opposites, which means the same number but with different signs. So I'm going to multiply 2 by -2, and I'm going to get an opposite. So we'll just see how that looks. So I'm going to write 1 down just the way it is. So I've got 4x plus 3y equals 19. I'm not changing that one in this case at all. 2, I'm going to multiply by -2. So -2 times 2. And that's going to give me, so -2 times 2x is -4x. -2 times -5 is plus 10y. And -2 times 3 is -6. And whenever I'm doing these, I actually do physically point to one and then the other, just like that, to figure it out. That way I make sure I'm not forgetting anything. Okay, so 4x minus 4x, well, that's just 0, so those canceled out. Now 3y plus 10y, that's 13y, and 19 minus 6 is 13. Well, that works out nicely because when I divide by 13, I get y is equal to 1. And there, I know what y is. And now I do exactly what I did before and just take this y and substitute it back into one of these equations. Again, either one works. I'm going to pick 2 because it doesn't have a 19 in it. Basically, that's the only reason I'm picking that one. You could do it for either. So 2x minus 5y, which is 1, equals 3. 2x minus 5 equals 3. So I add 5 to both sides. And I get 2x is equal to 8. Now I divide by 2, and x is equal to 4. So my solution would be 4, 1, right? X is equal to 4, y is equal to 1. And again, we should always check that. And so we'll do a quick check. In this case, because it doesn't ask you to do the check, you wouldn't have to show it, but you should still do it because why not if you can make sure that your work is right. So one thing I didn't mention before, always check in your original equations. Don't use something else because you might have made a mistake when you were doing something in here. And you always want to make sure that it works out with the original ones. So to check in 4x plus 3y equals 19, 4x. And then we're going to check in 2x minus 5y equals 3. So here we're going to have left-hand side and right-hand side. This left-hand side is 4, x is 4 plus 3 times 1, and that's 16 plus 3, which equals 19, and this equals 19, so that one works. And then over here, we've got 2, and again, x was 4, minus 5 times 1 equals 8 minus 5, which equals 3, and this equals 3 also, so that's right. And we know that this is, in fact, our solution.